So our next speaker is our own Emil Backmark. So Emil is a CI/CD architect working from Ericsson, and yeah, a co-chair of CDEvents and maintainer of CDEvents project. So take it away.
Thank you very much. Okay, so welcome back everyone from lunch. I have the opportunity to keep you awake the first hour after lunch, see if I can manage. So I will talk about Eiffel. You heard the name. If you've been here the whole morning, you heard the name at least twice this morning. And I will try to tell you what it is about, why it was invented and created, what it really is, and what we think could be the future of Eiffel. First, I want to express my congratulations to Norway. It's a national day in Norway today. I'm not sure if there's anyone related to Norway, but gratulerer med dagen. Yeah? Let's get going. So the agenda for today, why Eiffel then? And then, what is it really? And the future of Eiffel. To understand why Eiffel was created, I want to take you back in time, 10 years, to 2012. In Ericsson at the time, we had hundreds of development teams. We developed mobile systems by then, 2G, 3G, 4G systems in parallel. Hundreds of teams with thousands of developers in them. We integrated our products in multiple levels, from low-level libraries, through components, through some delivery modules, and to load module containers, which were eventually deployed in the customer. That we built ourselves. That's the product dimension, the architecture dimension of the situation we had in Ericsson at the time. To build these systems, we used some different tools. Our version control system was ClearCase at the time. I'm not sure many of you are familiar with ClearCase. Sorry? SVL? No. We used ClearCase. We used Hudson quite a lot. Jenkins was coming to the picture in 2012, I believe. We were starting to look into that. And we had a lot of internal tools. Continuous integration was a thing at that time, and Agile. We started to use those practices as well in our production. So our production system had some needs. We needed to be able to visualize what goes on in these builds. We called it the production system, by the way. That's the whole pipeline from source commit into the delivery towards the customers. So we need to visualize what happens. We need to calculate lead times from commit through different build processes and test processes all the way to the end. We also needed to be able to trigger, since we are so many developers and so many teams with all these integration levels, we needed to automate the triggering of these deliveries and the uplifts of the baselines for these deliveries. And one way that we came up with to handle these things was to start using event-driven continuous integration. So at that time, we invented the Eiffel protocol internally in Ericsson. So it was a completely internal thing at that time. We started to call it Eiffel, and we invented a lot of different event types. Trial and error way. Then 4 years later, the difference is marked with a bit bolder lines here. So quite the same picture when it comes to our product and architecture. We started to use a bit more of commercial hardware. And then these integrations, of course, were a bit different when it came to integrating towards the commercial hardware than instead of the proprietary hardware we used before. But the main differences might have been seen, at least from our end in the production system, on the lower level there. We started to use Git, still not Subversion. Git, but ClearCase was still around quite a lot. We used Jenkins, still a lot of internal tools. This glue code you've heard of today as well. We had a lot of that. But we started also to use open source software. Of course, Jenkins, but others as well. Continuous delivery also came into the picture. Not just continuous integration, but we also delivered continuously. And that's what it looks like in 2016. So then, what does it look like today then? Not a very big difference again. So, of course, we start to use cloud infrastructure, both for our product deployments and also in the production system. Still, I would say we have these multiple integration levels. Maybe you can argue if they are still actually integrations in the cloud infrastructure, but bear with me. I think that we do integrate. Of course, maybe we build and deploy smaller pieces, but so the integration doesn't maybe happen on the build level anymore, but it more happens in deployment instead. So we have, well, deployment dependencies and integrations of our builds, of course, in the system still. Sorry. And yeah, we started to use Argo. Since we went more cloud native, we started to use Argo as our workflow engine instead of using Jenkins. Well, we still use Jenkins, and we used at the time. But we started to introduce Argo a few years back. Actually, when we did that, Tekton wasn't yet a thing, so that's why we choose Argo workflow. Still, a lot of internal tools, and also an increasing amount of open source software to handle this cloud-native new world that we all went into. Continuous integration, delivery, and also continuous deployment. We have some customers actually that are brave enough to let us deploy our mobile systems to them continuously. And when it comes to version control, we still have clear case installations, I must admit, but we use Git almost only. So that's our situation today. We still see the need for Eiffel, the protocol, internally in Ericsson, even though we are moving towards a cloud infrastructure. So, what is Eiffel then? What is it really? Well, there are two aspects to it. There is an event protocol, a specification, if you will, and there is also an ecosystem of tools surrounding this event protocol. When we say Eiffel, we primarily mean the protocol, but there is also an ecosystem that the community is working with. So, just 2 slides before we go into deeper in the protocol itself. There's an Eiffel community on GitHub. It was formed then when we open sourced Eiffel in 2016. Nowadays, there is a formal technical committee of this community since 1 year back, and we have 3 different companies represented in the technical committee. And this is a picture of a famous landscape picture, and this is the Eiffel one. In the middle here, you can see the Eiffel protocol repository. That's the Eiffel thing. It looks very small in this picture, but it's maybe actually the main part of the community. Surrounding that, we have a lot of different tools in this Eiffel community organization in GitHub. There is one, and will come more tools that are Eiffel aware, but are not really contained within the GitHub organization of Eiffel community, but instead in others. This is a Jenkins plugin where we develop Eiffel support for Jenkins, and that's then located in the Jenkins organization in GitHub instead. Okay, and that's all I intended to say about the ecosystem part of Eiffel. Now, the rest of the talk will focus on the protocol itself. The protocol is built up of some different event types. So the semantics is very important to Eiffel. To the right here, we see all actually event types that are currently defined in Eiffel. I've grouped them in different areas to easily see what they are. So the yellow ones are test-related events. The green ones relate to source changes, when you want to notify that something has happened in your source control system. The blue ones are about activities, as we call them in Eiffel. And an activity, I want to say already now, an activity could be a complete pipeline thingy. It can be a step, it could be a stage, it could be a job, a build, anything that has a start and an end, more or less. That's an activity to Eiffel. And they can then be hierarchical. So a pipeline activity can contain pipeline step activities and so on. The red ones are related to artifacts. and there are some few more event types. The syntax of an event, then. What is really an event? Well, an event is essentially a JSON blob. To the left, you see the most simple variant of one of the event types, which is called activity started. You can see here the activity type for this. Sorry, the event type is Eiffel activity started event. That's what we call this activity started event, really. All the events in Eiffel have a strict syntax. So there are always 3 different objects on the top level of the of the JSON blob. So there is a meta field, the meta object, which is the same for any event type in Eiffel. Then there is a data object, and there is a links object. I will come back to the links object a bit more in detail later on. So the meta object, as I said, is the same for all event types, and there are a lot of different properties. These are the 4 mandatory properties you need to have in the meta object. There is an ID, which is a globally unique UUID. Then there's, again, as I said before, the type there, stating what event type is this. And there's a version of the specification, and there is a timestamp stating when was this event created. Then you have the data object, which is different for each event type we have. So depending on event type, there could be different mandatory and optional properties in the data object. And then we have the links object here, which I will explain a bit more in detail soon. To the right here, you see the same event type, actually, activity started event. You might not be able to read this, therefore I added it here, and I just want to say that this is another view of the same event type, with a lot of optional parameters added to it. I don't intend to go into detail, but just to show that there could be a lot more information in one event than the mandatory information. So let's take a small look into some of the event categories then. So starting with the activity-related events. These about starting and ending a pipeline or a step or a build or something like that. So an activity-triggered event is what you would send if you want to say that now I have queued an activity to be started. Something to be built, something to be tested, something to be started in some way. Put into queue. That's what you say when you send the activity-triggered event. And the activity-triggered event has only one mandatory field. That's the name field in its data object. And then there are a lot of optional fields, but those we can leave for now. Then when this activity starts, you would send an activity started event from your system. The activity started event actually doesn't have any mandatory fields, as I said in the previous picture there. It has, though, some optional parameters. For example, that we see here, we have execution URI, which points to the execution you're performing. Could be a path to a Jenkins host where your build is running. And then we have something called live logs. That's more or less where you can see live what logs are currently being created from your activity. And there are more that can be added if you like. An activity finished event then has one mandatory part in its data. It's the outcome. You need to state if this activity was successful or failed or some other kind of outcome. And there are some optional properties, for example, persistent logs, where you would like to say that the logs from this activity are now persistently stored in this location. So now we see 3 different events here. How can we then know that these events come from the same actual execution of this activity? And that's now where the links come into the picture. So let's go back to the activity triggered event again and look into some more details there. I mentioned a few slides back that there is an ID field always in the meta object, which is a UUID, a unified ID. This ID is very important when it comes to this links concept that I will just now describe. So what happens in the activity started event is that you would add a links object here with a reference which is the ID of the event you want to reference, or link to, as we call it in Eiffel. So in this case, we add the ID of the activity triggered event. It's not a full URI or anything like that. It's just an ID, the same ID as was sent in the meta.id field in the activity triggered event. And then we also state what is this link type. So in this case, for the activity started event, the link type is used is called activity execution, stating that the activity that I started is this activity execution, which was then previously announced by the triggered event. And similarly, when we come to the activity finished event, we will have the same link there. So both those different events reference this triggered event, so we can understand their relationships to the activity itself. Just quickly, another type of events, artifact-related events. We have something called artifact created, which means that some kind of build has been done. There is an artifact created with a certain ID on it. I haven't yet said that it's published anywhere. It's just created. So it has its ID. So as soon as your build system has built this artifact, you could send this artifact created event without having published it or tested it or anything. Just want to say that now I've built it. So there exists in the system somewhere an artifact with this specific ID and version. Then maybe you have some test activities, you probably have, where you would test this artifact, probably deploy it somewhere and test it, and then you would send a confidence level modified event. If you were here just before lunch, Eric talked about confidence labels. In Eiffel, we actually call it confidence levels, but it's the same thing. I would explain it like, I think Eric made a very good explanation, but it's how confident you are on a certain subject. And the subject here in this case is the artifact that was created. You could call it maturity or a stamp or badge or whatever, but we call it confidence levels in Eiffel. So similarly to the activity events, there is a link here, and in this case it points towards the artifact created events, meta.id field, and the link type is then a subject. Similarly, we could then publish the artifact once we have tested it enough and we think it's worth publishing. Then we send an artifact published event with a link to the same artifact again, saying that the artifact with this ID is now published on this location. So the optional field there is the location. You want to state where have you published this. And the link type here is artifact, not subject. So it means, I mean, it should be possible to read just looking at the link types about the relationship between these different events. So the artifact that is published is the created one. In the confidence level modified case, it's the subject of this confidence level is that artifact. It could be something else. It could be a source change or something else. So looking into a bit more complex example with these links then. In the bottom you see a quite simplistic pipeline, very simplistic pipeline, where you first see that your source code has been merged, and that merge would then trigger a build of some kind, and then a test activity, and then eventually you would deliver it if it's all successful. To notify about the source change, we send a source change submitted event in Eiffel, containing the reference to the actual commit or pull request or whatever you want to notify it with. Then the build activity starts with a triggered event, started and finished events. And then in between the started and finished events, you would most certainly send events about the actual artifact being built. Here we see a new event which you didn't see before, the CD event, composition defined. Eric also talked about compositions earlier today. So composition is the grouping of the content that this artifact is built from. So in this case, it's just one link from the composition to the source change event in this case with an element, but the composition could contain arbitrary number of other artifacts, libraries, or whatever that you want to build into this new artifact. And then an artifact created event is sent with a composition there. And I think I need to rush this a bit. Then we come to the test activity. Triggered, started, finished again, similar thing. We have some test suite events going on there, also referencing the activity. I didn't mention that. So there is this context link here as well, which you have seen in several places. That link is there to say in which context was this test suite executed, namely the context of this test activity, and the same for the build and so on. Then there is also the cause link here, stating that, for example, the cause of this build activity being triggered was that there was a new source change submitted. The cause of this test activity being started was that the build activity finished successfully, and so on. Similar for publishing or delivery, if you wish, something. So, what are all these links good for then? Well, and why are they so important to the Eiffel protocol? Well, they are needed since the events are quite thin in Eiffel. We don't duplicate data between events. If you have already said in the artifact created event what ID the artifact is, you don't add it again to the artifact published event or the conference load modified event. Instead, you reference to using these links. And with a graph of these linked events, so all the boxes here are like events, and then the arrows are these links between the events. You can trace events, end to end to find what has happened in a complex production flow. All the way from the earliest source code commit to the left until a customer deployment and beyond to the right. You can also trace forwards, or downstream as we normally call it, to find out, for example, where a certain application has been deployed, even if those deployments are made in different target environments and in different customer networks even. We can also trace upstream or backwards to find out, for example, what source change were involved in a certain artifact version, if those source changes were made by different organizations and maybe in different SCM systems even. So this traceability is crucial. When you, for example, find a bug or a security vulnerability in deployment somewhere, you would like to trace it back to the source code level to see where it came from. And then when you have found where in the source code this bug was introduced, you would like, again, to trace forwards to see in which deployments at our customer sites has this source change been used. So which deployments are affected by this vulnerability that we find in some other deployment somewhere. That's the strength of these links that we have all over. Just short, there is more things to links. I cannot mention it all due to time restrictions. But there was a recording from last year's CDCon in 2021, a year ago, where I discussed linking a lot more. So please go to that recording if you're more interested in what links could help you with. So now you might have wondered, how can we then find all these referenced events? As we don't include all data in all events, but instead reference previous events. How can we make sure that those events are found and seen where they would need to be? So there are at least 3 different things you can think about there. There could be one central store for all events in your global world, where you can always go to find these events. Or there could be domain stores where you would store events for a certain domain or for a particular type of events, category events or something like that. Or you could have events stored in the consumer end, in your visualization tool or in your KPIs, metrics tool or whatever. I think that the best way would be to have a combination of these. I would see the consumer stores more as a cache. And then if some events are not found there, they could go to some more centralized or domain store to find the actual truth of all events being sent in history, as long as that history is of course, interesting to keep. So who is then using Eiffel? And this might actually come as news to some people in the room who are anyway familiar with Eiffel already. But there are Ericsson, of course, the company I represent, is there. Axis Communications, a company in the camera surveillance business, and Volvo, Volvo Group. So these Ericsson and Axis and Volvo are the companies that are involved in the technical committee for Eiffel right now. And just a few weeks back, we learned that Nasdaq, the stock market company, is actually using Eiffel in production as well, which was news to ourselves just a few weeks back. So, quickly then, about the future of Eiffel. What do we think about the future? I mean, this conference is all about CDEvents, and now I just talk about Eiffel. What's the thing? What's in it for us, and what's in it for you? So, I just want to repeat what the picture looked like before, in 2022, our situation by then, without going into repeating all the details. And what do we think then about the future in, say, 4 or 6 years or whatever? I think that we will move even further into cloud infrastructure. We will still have these integration levels, but they will probably not be, as I said before, on build level. They will rather be when we deploy things. So we will have the integration going on in the cloud instead. All the microservice being integrated into larger applications or whatever. We will still have the needs in our production system to calculate lead times, visualize what's going on, trigger these deliveries, and perform baseline uplifts. Even though the baseline uplifts might not, again, then be in source code level or before we build things, but rather on the cloud itself. And I think we will use more and more open source. There's a clear direction in Ericsson saying that we shouldn't develop all this glue code, that we actually still do. We should try to, as much as possible, contribute and gain from the open source communities all around. I would guess that Tekton could replace parts of our Argo deployments. I don't know, we'll see how it turns out. So what about the thing that could put this together then? It could be CDEvents. So if CDEvents is successful, and if it becomes native in many of these different open source products that we use, I would guess that we would move from Eiffel to CDEvents. But it more or less all depends on you guys and everyone in the CDEvents community to help out making this a success. So some experience just in the end here that we bring from Eiffel, from the Eiffel community, and from the work we have done with Eiffel over the years to the CDEvents project. We think it's important to build a community early. We think also that it's important to build an ecosystem around the protocol and not just providing a protocol without any useful tools around it. And as you've already heard that, there are proof of concepts and SDKs already. Just after my talk now, we will hear more about the proof of concept from Vibav. And there's a need to have getting started information, or it needs a way to get started. And that of course, is very much enabled by the cloud native and the Kubernetes deployments that we can have today. So it should be very easy to get something started quickly using these events. We should consider generalness versus specificness. That might be a bit strange, but what I mean is that, for example, for a source change event, in the Eiffel world, we have one kind of source change events dealing with any kind of SCM system. So both ClearCase, as you saw before, and Git, they are both notified using the same event. Maybe that's not always the best fit. because ClearCase and Git, they have two quite different paradigms when it comes to source control. So there might be a reason to actually divide these in two different categories of source change events instead. So things like that we need to be considerate about. We should also combine CI/CD paradigms. I mean, what the tools in the CI/CD domain look like with experience from research in academia and architecture. In Eiffel, we have mostly actually used research-based evolution of the protocol and the architecture of, I mean, CI/CD system architecture on a high level, and not that much looking into what can the CI/CD tools help us with. So we should have a good combination there as well when we develop CDEvents. We should focus on documentation before features. It's more important to have a well-documented protocol than to have a lot of fancy features in the protocol. And we should use existing event infrastructure framework. When we developed Eiffel, Cloud Events wasn't around, but now it is, and I strongly believe that that's a good thing to build on top of. That makes us independent on the infrastructure on which the events are flowing, and we can focus on the actual semantics of the events themselves. Here it has a slide with links. You can have it afterwards. And my last slide. Bottom line, what to communicate is volitional, but how to communicate it is not. Meaning, you can say whatever you want from your system. You can tell if you want, you can tell about activities being started or finished or whatever. You can tell about builds being done. But if you want to talk about a build, then this is how we should do it. So that, and the intention there, of course, is that the consumers of these events should always be able to understand what is the message that was given to me. So there shouldn't be any different ways of providing these messages. And that's the end of my presentation. Now it's up for questions. Eric?
Thanks. Emil, you mentioned that there is an ecosystem around Eiffel, and I was thinking, do you think there are some parts of that ecosystem that would be interesting to have either adapted or rewritten for CDEvents because they fill an interesting purpose in Eiffel, and we should have something like that for CDEvents, like event repository or something like that?
For sure. So I didn't mention much about what the actual parts of this ecosystem is, but I think that the parts in this ecosystem are needed to be able to provide a well-functioning, event-aware CI/CD system. So for sure, we need somewhere to store events, and we should cooperate around some kind of store. There could be multiple stores. It doesn't really matter if there's just one way to store events, but we need to have ways to store events, of course, in the ecosystem. And also, we need to have plugins, hopefully native plugins to the different CI/CD tools in this ecosystem as well. And means to send and receive events and understand them, these SDKs that people have been talking about earlier today as well.
So there could be an opportunity for people in this room or for the rest of the community to, rather than having to sit and come up with projects to build, look at the Eiffel ecosystem and say, okay, this one seems interesting. I want to build one of these for CDEvents.
Sure. Why not?
Thanks.